Which of the following tables represents a linear relationship that is not proportional? Okay, so if you think about what proportional means in an equation, proportional is when I only am multiplying. Or you can even think about, like, for example, 2/5 is proportional to 4/10. So I have like an equal relationship. Again, I'm only multiplying to get from one thing to the other thing. Okay, so there's lots of ways to check this. I'm looking at a -6 over -3 equals +2. So I'm putting y over x. -2 over 1 is +2. So I should be multiplying by 2 each time. So if I go down and keep checking, -3 times 2 is -6. -1 times 2 is -2. 0 times 2 is 0. 5 times 2 is 10. So this one is proportional. So I'm going to get rid of that. Okay, looking at B, -2 times 5 is 10. And 1 times 5, though, is not -5. And 3 times 5, oh, I'm sorry. Let me go back. I made a mistake. -2 times -5 is +10. 1 times -5 is -5. 3 times -5 is -15. And 6 times -5 is -30. So since it's multiplying by the same thing each time, that would also be proportional. So I'm going to get rid of that table. Okay, so looking at C, it's kind of a little bit more difficult for me to see what it's multiplying by. So that's when I might actually do my y over x for this situation and put it in my calculator. So 14 over -3. And I might type that into my calculator. So 14 divided by -3 is -4.6 repeated. And then I'm going to do 11 divided by -2 and see if it's the same. And when I do that one, I get -5.5. So 11 over -2 equals 5.5. Okay, so this one is not proportional because they equal different things. I'm not actually multiplying by the same thing to get to the other. So C would be my answer. Okay, number 8, which of the following mappings does not represent a function? So a function is when each input, or x value, is matched to one y value, or output. So x is matched to one y value output. So if I look at A, -1 is matched to -3, 0 is matched to 0, 1 is matched to 2, and 8 is matched to -3. So each x value is matched to only one y value. So this one is a function, so that is not my answer. B, -5 is matched to -3, 7 is matched to -2, and 9 is matched to -1. So this is a function because each x value is matched to one y value. C, -4 is matched to -1 and 1. 2 is matched to 5, and 7 is matched to 9. So if I look right here is my issue, -4 has 2 outputs. So C is not a function. So this should be my answer, but let's look at D. D, -7 is matched to -2, 0 is matched to -2, and 5 is matched to -2. Even though they're all matched to the same output, this is still a function because each x value still only goes to one y value. So that is okay. So this one is still a function. So C is definitely my answer. Number 9, which of the following is not a rational number? Okay, so looking at my diagrams of real numbers, we know all of our numbers are real numbers, but which one is not a rational number? Well, 19 is a whole number, so that means it must be a rational number. 0 is a whole number. Well, actually, 19 I can put in natural numbers. So 0 is a whole number. -4 is an integer. And square root of 8. Now, square root of 8, I actually would need to type into my calculator to calculate what square root of 8 would be. So if I type in square root of 8, I get this repeating decimal of 2.82843. Actually, it's not repeating, it's an ongoing decimal. So I approximately get 2.83, but it goes on. So I don't know how long this number is. I can't actually get an exact amount for square root of 8. Square root of 8 is an irrational number. Now, if I had something like square root of 16, square root of 16 equals 4, so that would not be irrational. But square root of 8 is irrational because I can't get, I can only estimate it like pi. Number 10, order the following numbers from least to greatest. Okay, so I think when we have calculators, the easiest way to order our numbers is by changing them to decimal. So square root of 65, and my calculator is about 8.06. Then I have negative square root of 60, which would give me about negative 7.7. I have negative 8.5 is already changed, and 37 over 4 would be 9.25. So I want least to greatest. So my least, I'm thinking about my number line and where 0 would be. My least value would be negative 8.5. Then would be negative 7.7, which is negative square root of 60. So I'm working towards 0. Then would be 8.06, which is square root of 65. And then 37 over 4, which is 9.25. Number 11, the value of y varies directly with x. When y equals 75, x equals half. What is the value of y when x is 2 1/4? Okay, so on these problems, it helps me to build a table since I have y values. So if I have x and y, and I know that when x is half, y is 75. And I know this is varies directly, so that's another way to say proportional, meaning I'm only multiplying to get from my x to my y. Then I want to know what it is when it's 2 1/4. So I'm looking for this value here. So I'm looking at how do I get from half to 75? What is something I can multiply by to get half to 75? So how many halves would I need to get to 75? Well, I would need 150 halves to get to 75 wholes. Okay, so I would have to do 1/2 times 150 to get me to 75 wholes. So since this is a proportional relationship, I know I can take 2 1/4 and also multiply by 150 to give me my y value. So I'm going to take 2 1/4. Now in my calculator, I can't type in 2 1/4. So I'm going to have to type in 2.25 times 150. And I get 337.50. Wait, I'm recording. So B would be my answer. 337.5 would be 337.5. Okay, number 12, a preschool has a rectangular field and a rectangular playground that are similar in shape. Each dimension of the field is 3.2 times the corresponding dimension of the playground. Which statement is true? Okay, so each dimension of the field is 3.2 times the corresponding dimension of. So I'm just going to kind of imagine this. Let's just make up a playground. So let's say my playground's super small. Okay, we've got a little mini playground. Okay, a preschool has a rectangular field and a rectangular playground that are similar in shape. So let's say my playground is 3 and 2. And my field is 3.2 times the corresponding side. So let's draw my field. So my field would be 3.2 times. So I'm going to do 3 times 3.2, which is 9.6. And 2 times 3.2, which is 6.4. Okay, so I want to know what is true. So the area of the field is 6.4 times the area of the playground. Well, let's look. Well, my original area, my area of the playground is 6. And my area of my field is 9.6 times 6.4. So that's 61.44. So it's quite a bit bigger. It's like 10 times bigger. 6 times 10 is about 60. So it's not 6.4 times bigger. Let's get rid of A. The area of the field is 10.24 times the area of the playground. Well, let's try that. 6 times 10.24. So 6 times 10.24. That equals 61.44. That's exactly what I wanted. That's what my area was. So B must be my answer. Number 13, triangles PQR and RST are similar right triangles. Which proportion can be used to show that the slope of PR is equal to the slope of RT? Okay, so we know that we can actually find the slope from either of these. This would be 1, 2, 3, a rise of 4 over 3, and this is a rise of 1, 2, 3, 4, 5, 6, 7, 8, and 6. And 4 over 3 equals 8 over 6. So I'm looking for a proportional that's a proportion that's like that. So if I look at how I find a rise, I'm actually starting from my y value of 7 and moving down to my y value of 3. So at 4, I'm really taking those points and I'm subtracting those. So I'm taking my y value of 7 and I'm subtracting 3. And I would get, oh, actually, I should say I'm subtracting. Let me fix this a little bit because we know it actually should be negative 4/3. So I'm saying this backwards. I really should be taking 3 minus 7. Okay, or if you look on your formula chart, we're actually doing y2 minus y1 over x2 minus x1. So my slope formula. Okay, so 3 minus 7, those are my two values. Okay, so I can see I'm doing 3 minus 7 in A. Let's see if the rest of this matches up. Okay, and to find my run, I'm working backwards. So I'm taking negative 4, my second x value, and I'm subtracting negative 7 to get 3. So A so far is, and if I look at my second triangle, I'm taking my y2 value, so my s right here, which is at negative 5, and I'm subtracting my y1 value, which is 3. So negative 5 minus 3. And then I am taking my x2 value, t, and subtracting my x1 value, which is s. So I'm going to do 2 minus negative 4. So if you look at A, all of those pieces are matching up. Number 14, determine the value of x using the figure to the right. So I'm looking for the value of x, and if you remember, if I tear off this corner and this corner, it should fit inside this. So if I write that as an equation, 2x plus 3 plus 51 will give me 100. I'm going to simplify this. 2x plus 54 will give me 100. So now I just need to solve for x. So I'm going to subtract 54 on both sides. I'm going to have to bring this up here. So when I subtract 54 on both sides, I get 46 equals 2x. And then I'm going to divide by 2 my coefficient on both sides. So x equals 23. So A would be my answer. Number 15, what is the value of x in the diagram below? So if I look at this, I might want to use my patty paper to look at my two angles here. So my two angles here, if I traced my angles, the little, kind of like the little triangles or the corners, I would see that they are the same size, that they're congruent or equal. So I can say 2x minus 10 will equal 65 minus x. And then I can solve. So I'll add x on both sides to get rid of this x. So I have 3x minus 10 equals 65. I'm going to rewrite that so I can finish my work. And then I'm going to add 10 on both sides to get rid of the negative 10. So I have 75 equals 3x, and then I'll divide by my coefficient of 3. So x equals 25. B. In the sketch below, triangle ABC has an exterior angle ACD. If the measure of angle 1 equals 56 degrees and the measure of angle 2 equals 54 degrees, what is the measure of angle ACD? Okay, so if you remember, once again, that if I rip off this corner and this corner, it'll actually fit into this outside corner. So angle 1 is 56 degrees, angle 2 is 54. So the exterior angle is those two angles combined or added. So 56 plus 54. And 56 plus 54 is 110. Number 17, the measures of two angles are 5x plus 24 and 9x minus 17. What is the value of x if these angles are congruent? So what's the value of x if they are equal? So 5x plus 24 equals 9x minus 17. Okay, so I want to get x by itself, so I'm going to go ahead and subtract this 5x from both sides, leaving me with 24 equals 4x minus 17. And then I'm going to add 17 to both sides. That gets rid of this negative 17 or minus 17, which gives me 41 equals 4x. And I'm going to divide by 4. Dividing both sides by 4, 41 divided by 4 is approximately 10.25 B. Okay, number 18, the list shows the number of songs that 5 students each downloaded last week. What is the mean absolute deviation of the data? Okay, so first I am going to find the mean of my data, so I'm going to add all of them up. And I'm going to divide by how many there are. So I am adding all of those up and dividing by how many they are to find my mean. Okay, so I have 32 plus 43 plus 38 plus 28 plus 51. So I get 192, and I want to divide that by 5. 38.4. Okay, so this is my mean, not my answer. Okay, so I'm going to get rid of 38.4 so I don't make a mistake. And I want to know the distance, the average distance that each of these are from 38.4. Okay, so this 32 is 6.4 away. 43, I'm going to have to subtract that. So I'm going to come here. I'm going to do 43 minus 38.4 is 4.6 away. 38. So 38 is 0.4 away. 28 is 10.4 away. And then 51, I'm going to have to subtract that one too. So 51 minus 38.4 is 12.6 away. So now I have found the distance that all of these are from 38.4. How far are they from it? And now I want the average distance. So I'm going to take those same numbers. I'm going to add them all up. 6.4 plus 4.6 plus 0.4 plus 10.4 plus 12.6. And I want my average distance. This is my total distance. So I'm going to get rid of this one so I'm not confused. Mean absolute deviation is typically going to be a small number. And I'm going to divide by how many there are to find my average. 1, 2, 3, 4, 5. So I have 5 distances. So my average distance is 6.88. Number 19, Veronica is ordering trophies for her school. Company P charges $3.50 for each trophy and a one-time engraving fee of $25. Company R charges $7.50 for each trophy and a one-time engraving fee of $17. Which inequality can be used to find X, the minimum number of trophies that can be ordered so that the total charge at Company P is less than the charge at Company R? So I want Company P to be less than Company R, and it helps me to write it out in words first and then get to my numbers. So what about Company P? Company P charges $3.50 for each trophy. So $3.50 for each would be $3.50x plus a one-time fee, so plus 25. I want it to be less than Company R, which does $7.50 for each trophy, so $7.50x, and a one-time engraving fee of 17, so plus 17. Okay, so I'm looking for this. Okay, so I don't want to just look for my symbol. Be very careful about that because that can get a mistake. But I see right here, I have 3.5x plus 25 is less than 7.5x plus 17, which matches my inequality that I wrote. So B. Number 20, which graph represents y as a function of x? Okay, so for a graph, I'm going to use my vertical line test. I want to make sure that each input, my x values, each x value only has one y value. And my vertical line helps me see that. It helps me see what y values I have for an x value. So I want which one is a function. So each x value can only have one y value. So if I look at the first one, notice that I have a vertical line. So I have lots of y values for this particular x value. This is like 1.5. So for 1.5, I have all of these y values. So this is not a function. So I'm going to get rid of this one. Not a function. Okay, let's look at the next one. So if I imagine vertical lines, I've got an x value here, and here, and here, and here. Anywhere on my x-axis represents my inputs. And now I can look to see my outputs for each. So my line crosses right here at this x value, and right here, and right here. At no point do I have more than one y value for each x value. Okay, so let's look at the next one. So I think this one's a function, but let's look at the other ones and make sure that we're not missing anything. So if I look at the next one, you can see no matter where I draw a vertical line, that my x values have more than one y value. So this x value right here has a y value here and a y value here. And this x value has a y value here and a y value here. So it has two y values for an x value. So this is not a function. And then my last one, you can see a circle, no matter where I draw my vertical line, that there's going to be two y values. So this is not a function either. So my function is my second graph. Okay, number 21. Carolyn will buy the same number of stamps every month to add to a stamp collection her grandfather gave her. The table shows the number of stamps Carolyn will have at the end of X months. Okay, so let's look at what's going on in our table. So here's my months. So I can see it's increasing by 2 months here, and 3 months here, and 4 months here. After 2 months, she's gained 100 stamps. So she's gained 100 stamps for 2 months. After 3 months, she's gained 150 stamps. So 150 for 3 months. And then for 4 months, she's gained 200 stamps. So 200 stamps for 4 months. So let's see what's true. Carolyn was given 200 stamps. Well, I don't know that. So I'm not going to go there yet. And she will buy 50 stamps every month. Okay, well, that would make sense, 50 stamps every month, because 2 months is 100 stamps. So 1 month would be 50 stamps. Okay, so it could be A. Carolyn was given 180 stamps and she will buy 70 stamps each month. No, not 70. Carolyn was given 180 stamps and she will buy 50 stamps every month. True. Carolyn was given 200 stamps and she will buy 70 stamps every month. No. Okay, so we know this part's true. We're looking at this 200 and 180. How many stamps was she given? So in this particular case, I would look at my table and I can see that if I go back to 0 months and she's earning 50 each month, that means that she would have 200 stamps. So my initial value is 200, so A would be my answer. Okay, number 22, which situation represents a proportional relationship? The cost of purchasing a basket of oranges for $1.30 per pound plus $5 for the basket. Well, $5 would only occur one time. So I wouldn't only be multiplying, I would need to multiply and add. And I want to only be multiplying for a proportional relationship. So A is wrong. The cost of purchasing peaches for $7 per box of peaches with a delivery charge of $3. So here I would multiply. That's fine for a proportional relationship. But then I would add. That makes it not proportional anymore. The cost of purchasing grapefruit for $1.80 per pound with a coupon for $1 off the total cost. So this one I would multiply, but then I would need to subtract. So I don't want C. D, the cost of purchasing apples for $1.75 per pound and multiply. And a shipping fee of $16 per pound. Oh, I would be multiplying again. So I have two multiplying relationships and it's with the same thing. Notice it's per pound. So really I'm doing $1.75 per pound and 16 cents per pound. It's going to increase by the same amount each time. It's going to increase by $1.75 and 16 cents each time. So I really could rephrase this and I really could add these together and say per pound for those. So D is my relationship because I'm only multiplying. Okay, last question, number 23. Frankie bought a new computer. He made an initial payment of $50 to the store and he will pay $30 each month. Which equation represents the relationship? The number of monthly payments Frankie has made and the total amount that Frankie has paid the store. Okay, so if I look at this, I first noticed that it says $30 each month. So I'm rid of A and B, $30 each month. And it says the total amount that Frankie has paid the store. So I'm not going to take away the $50 he paid, but I want to add the $50 he paid because I want the total amount he paid, which would mean that I need to add those pieces together. So D is my answer.